Hello friends, welcome back to all about structural analysis and design. In our previous video we have gone through a concrete mix design according to Indian standards 10262-2009, but it was without any chemical admixture. So in today's video we will go through a concrete mix design with the help of chemical admixture, that is Superplasticizer, and also go through the adjustments of water, fine aggregate and coarse aggregate when the aggregates are in dry condition. So you will be getting the link of my previous video without the use of chemical admixture, so you can go through that particular link. So we shall begin with this today's lecture. So the first thing is stipulations for proportioning. So the grade designations they have mentioned is M45. So before we proceed, I would like to tell you what is meant by this M45. This M is nothing but the mix design of concrete, and 45 is nothing but the compressive strength at the end of 28 days in Newton per mm square. So the type of cement is used as OPC 43 grade. So the maximum nominal size of aggregate is 20 mm. So the exposure condition they have mentioned is very severe, and the concrete you are going to use is for reinforced concrete, and the workability is 125 mm slump. The method of placing is CUTE, that is non-pumpable concrete. Type of aggregate is crushed angular aggregate. Maximum cement content is 450 kg per meter cube, and the chemical admixtures which we will be using in this particular design is Superplasticizer. So if you look at the stipulations, they have not mentioned the maximum water cement ratio and minimum cement content. So you have to use the IS 4562-2000 code, which is exclusively for reinforced concrete code. So the exposure conditions they have given very severe. So from that particular code you have to get the maximum water cement ratio and also the minimum cement content for that particular grade of concrete according to exposure conditions. So the test data you require, that is cement, again it is used as OPC 43 grade. Specific gravity of cement they have given as 3.12. Chemical admixture used is Superplasticizer. Specific gravity of coarse aggregate is 2.72. Fine aggregate is 2.65. Superplasticizer is 1.145, and the water absorption of coarse aggregate is 0.6%. Fine aggregate is 0.9%. Then surface moisture is nil for both the coarse aggregates as well as fine aggregates, and the fine aggregates which you are using is from zone 1. So the first step in the concrete mix design is target strength for mix proportioning. So if you can go through my previous video, I have explained what is target strength and what is standard deviation. So in this particular step we will be getting this F-CK. It is nothing but target average compressive strength at the end of 28 days of curing. FCK is characteristic compressive strength at the end of 28 days of curing. S is standard deviation. So from table 1 page number 2 from IS 10262-2009, so you will be getting this standard deviation value. S is equals to 5 Newton per mm square for M45 grade of concrete. So there are various standard deviations with respect to the grades. So for 45 Newton per mm square or M45 grade, the S value, that is the standard deviation value, is 5 Newton per mm square. Therefore the target strength value is equals to 45 plus 1.65 into 5, which you will be getting as 53.25 Newton per mm square. So the next step is selection of water cement ratio. So for that thing you have to refer the table 5 on page number 20 from IS 456-2000. So the exposure conditions they have mentioned is very severe, and they have not mentioned maximum water cement ratio and minimum cement content for this particular grade. So maximum water cement ratio for very severe exposure condition, that is for reinforced concrete, is 0.45, and minimum grade is M35. This sentence I have taken from referring the table 5 from IS 456-2000. There are various exposure conditions ranging from mild, moderate, severe, very severe and extreme cases. And there are two types of concretes, plain concrete and reinforced concrete. And for the reinforced concrete, for a very severe condition, the minimum grade of concrete is to have is M35, and the minimum cement content is 340 kg per meter cube, and the maximum water cement ratio you can provide is 0.45. And in our case we are designing for M45, so which is greater than this M35, therefore okay. And we shall adopt water cement ratio as 0.42. 0.45 is the maximum, we cannot exceed, and with the experience we can design it for 0.42. Therefore 0.42 is less than 0.45, therefore okay, and we can proceed in the mixed design. So the next step is selection of water content. So for this you have to refer table 2 page number 3 from IS 10262 2009. So the maximum water content for 20 mm aggregate is 186 liters. There are three types of nominal aggregates which is mentioned on table 2, that is 10, 20, 40. For 10 it is 208 liters, for 40 it is 165 liters, and for 20 it is 186 liters. Okay, and you have to remember these values are for the slump values 25 to 50 mm. So for every additional 25 mm slump, increase 3% of additional water. So for example, if you are going for 75 mm slump, then you have to increase 3% of additional water to this 186 liters. So this information you can get from IS 10262 2009 page number 3. So the given slump in our problem is 125 mm. Therefore the water content has to be increased by 9%, and therefore the water content for 125 mm slump is equals to 186 plus 9% into 186, which will be getting 202.74 liters, which is approximately 203 liters or 203 kg per meter cube. And as this problem is by using this superplasticizer, therefore the water content can be reduced 20% and above. So based on trials with the superplasticizer which we are going to use in this mixed design, the water reduction of 24% has been achieved. Various types of superplasticizers gives the various water reduction, so the trials are necessary for carrying out this mixed design. So we have got 24% reduction. So the water content which you require for this mixed design is 203 liters, which was getting previously for 125 mm slump, into 0.76. We have reduced it by 24%. So you are getting 154.28 liters, which is approximately 155 liters of water. Previously it was 203 liters before using superplasticizer. After using superplasticizer you are getting 155 liters. So clearly you can see 48 liters of water is reduced for the same slump, that is 125 mm slump, with the use of superplasticizer. So there is a great reduction of water content. So the next step is calculation of cement content. So the water cement ratio is 0.42, and from this cement content you will be getting 155 divided by 0.42, that is 369 kg per meter cube. And from table 5 page number 20 from IS 456 2000, minimum cement content for reinforced concrete in very severe condition is 340 kg per meter cube, and whatever the cement you are getting in this particular design is 369 kg per meter cube, which is obviously greater than 340 kg per meter cube as it is mentioned in IS 456 2000. Therefore hence it is okay for the mixed design. And also the given cement content is 450 kg per meter cube as per the stipulations. Therefore you can proceed further in this M45 grade of concrete mixed design. So next thing is proportion of volume of coarse aggregate and fine aggregate content. So from table 3 IS 10262 2009 page number 3, so volume of coarse aggregate for 20 mm nominal size aggregate and fine aggregate zone 1 for water cement ratio 0.5 is equals to 0.6. So it will be getting the table number 3. They have mentioned the nominal size of aggregates again 10, 20 and 40. So again the fine aggregate zones they have mentioned, which varies from zone 1, zone 2, zone 3 and zone 4, and the sand which we are using for this mixed design is zone 1. So the table which it is given in IS 10262 is strictly for water cement ratio 0.5, and for 20 mm nominal size of aggregate we are getting for zone 1 of fine aggregate it is 0.6. the volume of coarse aggregate is 0.6, but remember the table is for water cement ratio 0.5, but in our present case water cement ratio is 0.42, which is less than 0.5. So there is one note here: for every plus or minus 0.05 change in water cement ratio, proportion of volume of coarse aggregates should be changed at the rate of plus or minus 0.01. So if the water cement ratio is decreasing, you have to increase the volume of coarse aggregate. So now in present case water cement ratio is lowered by 0.08. So 0.5 minus 0.42 is equals to 0.08. It has been lowered by 0.08. The proportion of coarse aggregate has to be increased accordingly by interpolation. So this note is only for valid when it is directly changing plus or minus 0.05, and you have to increase or decrease at the rate of 0.01. But this number is neither 0.45 nor 0.4. it is in between 0.4 and 0.45. so we have to go for interpolation method. So now by interpolation method for water cement ratio 0.42. so the table from the value from table you are getting for water cement ratio 0.5 is 0.6, and if you go to 0.4 it will be increasing as 0.62. Why? Because for every change of water cement ratio 0.05 there will be increase or decrease in the volume of coarse aggregate by 0.01. So 0.42 lies between 0.5 and 0.4. So we are going to interpolate between these two values. So 0.62, the bigger value first, minus 0.6 divided by 0.5 minus 0.4 into 0.5, the bigger value, and this value is nothing but for this water cement ratio you are going to find out the volume of coarse aggregate. So you are getting 0.016. So the corrected proportion of volume of coarse aggregate for water cement ratio 0.42 is 0.6 plus 0.016. So the corrected proportion is 0.616. So if you see here 0.42 lies in between this, and also this value 0.616 lies between 0.6 and 0.62. So the given method they have mentioned is from CUTE, that is non-pumpable concrete. So you need not decrease the coarse aggregate content. So you can keep volume of coarse aggregate content as 0.616. Therefore the volume of fine aggregate becomes 1 minus 0.616, which is equal to 0.384. Now the mix calculations. Calculations will be done for 1 meter cube of concrete. So the A point is volume of concrete, that is 1 meter cube. B point is volume of cement you are going to find out, that is mass of cement divided by specific gravity of cement into 1 divided by 1000. Mass of cement, if you remember, we have got 369 kg per meter cube divided by 3.12. This has been given in the test data for materials into 1 divided by 1000. So you are getting 0.1182 meter cube. Volume of water, again mass of water divided by specific gravity of water into 1 divided by 1000. So mass of water we have got after using Superplasticizer as 155 liters divided by specific gravity of water is 1 into 1 divided by 1000. So you are getting 0.155 meter cube. So now D point is a volume of Superplasticizer. So you have to remember how much to add this superplasticizer for this particular design. So we are going to add 1% by mass of cementitious material. So you have to take the volume of superplasticizer. For that you have to assume by mass. Assume means by it will be done by dosage for different trials, and you will be arriving at a particular dosage. So we are going for 1% by mass of cementitious material. So mass of superplasticizer divided by specific gravity of superplasticizer into 1 divided by 1000. So this 3.69 is nothing but 1% of cementitious material. Cementitious material is your cement. So the cement was 369 kg per meter cube. 1% is 3.69. 1.145 is the specific gravity of superplasticizer, which is given in test data for materials, into 1 divided by 1000. So it will be getting 0.0032 meter cube. So now E point is volume of all in aggregates. A minus in bracket B plus C plus D. B is nothing but volume of this one cement, volume of water, volume of superplasticizer. So you will be getting 0.7236 meter cube. Now from this volume of all in aggregates, you are going to find out the mass of coarse aggregates. So I have written here E point. E point is nothing but volume of all in aggregates into volume of coarse aggregates into specific gravity of coarse aggregates into 1000. So 0.7236 into volume of coarse aggregate is 0.616 into specific gravity of coarse aggregates, which is again mentioned in test data for materials, which is 2.72 into 1000. So you will be getting 1212 kgs. Mass of fine aggregates. E is nothing but again volume of all in aggregates. Volume of fine aggregates into specific gravity of fine aggregates into 1000. So 0.7236 into volume of fine aggregates is 0.384 into specific gravity of fine aggregates is 2.65, which is given in test data for materials, into 1000. So you will be getting 736 kgs. So the final mix proportion for this trial is cement is 369 kg per meter cube, water is 155 kg per meter cube, fine aggregate is 736 kg per meter cube, coarse aggregate is 1212 kg per meter cube. Superplasticizer at the rate of 1% of cementitious material is 3.69 kg per meter cube, and the water cement ratio you are going to adopt as 0.42. Okay, so you have to remember, but this above proportions are for only SSD conditions, that is saturated surface dry conditions, and they have mentioned the water absorption of your particular aggregates. Okay, but this is only for SSD conditions. Now comes into picture is this adjustments of water, fine aggregates and coarse aggregates. If the fine and coarse aggregates in dry condition, it may be in wet conditions, for that different calculations are there. So but in this case it is in dry condition. So the fine aggregates which are dry, how to find out? Mass of fine aggregate in SSD condition, which we have found out as 736 kgs, divided by 1 plus water absorption of fine aggregates divided by 100. So 736, which is nothing but in SSD condition, mass of fine aggregates in SSD conditions divided by 1 plus 0.9 divided by 100. So 0.9 was the water absorption which was given in test data of materials. 0.9 divided by 100. So if you calculate this thing, you will be getting 729 kg per meter cube. Correct? Previous was 736 in SSD conditions. If the fine aggregates are dry, you are getting 729 kg per meter cube. Similarly, you have to calculate for coarse aggregates for dry, which is mass of coarse aggregates in SSD condition 1 divided by 1 plus water absorption divided by 100. So mass of coarse aggregates in SSD condition was 1212 kgs and the water absorption was 0.6%. So if you calculate this will work out as 1204.7, which we have taken approximately 1205 kg per meter cube. Previous was 1212. So the dry condition is 1205 kg per meter cube. So now extra water has to be added for absorption by fine aggregates and coarse aggregates. So by testing we came to know that fine aggregates water absorption is 0.9% and coarse aggregates is 0.6%. So now if the aggregates are in dry conditions and when you pour the water while mixing, what happens is coarse aggregates and fine aggregates absorb the percentage of water. So to counteract that, we have to add extra amount of water. Previously we have calculated for SSD condition, right? And we are now calculating for the dry condition. So extra water has to be added to balance this proportion. So for fine aggregates is equals to mass of fine aggregates in SSD condition minus mass of fine aggregates in dry condition. So 736 was mass of fine aggregates in SSD condition and 729 is in dry condition. So if you minus this thing, you will be getting 7 kg. And for coarse aggregates, again mass of coarse aggregates in SSD condition minus mass of coarse aggregates in dry condition. So if you minus this, you will be getting again 7 kgs. So now total water to be added in this particular mix design is 155 liters, which we had previously got in SSD condition after using Superplasticizer. So plus 7 you have to do for fine aggregates and coarse aggregates respectively. So the total water becomes 155 plus 7 is equals to 169 kg per meter cube. So in SSD condition you required only 155 kg per meter cube of water, but as you are adjusting the water in this dry condition of fine aggregates and coarse aggregates, so you require the extra amount of water, correct? So the total water becomes now 169 kg per meter cube. So this is very important aspect in this mix design when you have to adjust for the dry conditions or wet conditions. So this particular example was for dry conditions. So now at last this proportion, mix proportion after adjusting for dry aggregates becomes cement will be as it is 369 kg per meter cube. Water is now increased from 155 to 169 kg per meter cube. Fine aggregate, the aggregate value has been reduced to 729 kg per meter cube. Coarse aggregate, again it is reduced, it is 1205 kg per meter cube. Superplasticizer at the rate of 1% of cementitious material you are using, and it will become 3.69 kg per meter cube as it was previously in the previous calculations. And the water cement ratio you are maintaining as 0.42. So now this is the last proportion which you are using after this adjustments for dry aggregates. So I hope I have cleared all the doubts regarding this mix design after adjusting for dry aggregates, and also I think I have cleared the doubt for interpolation method also to calculate the volume of coarse aggregates. So if you like my video, please press the thumb button and share this video, and also subscribe and click the bell icon for my latest updates on the other structural engineering or civil engineering videos. So I thank you guys for watching patiently this video. Thank you once again.